Good afternoon, everybody. Welcome on this Monday hot and sticky afternoon. Even though I've got air conditioning still outside, it's hot and sticky. Another adventure into organic chemistry with Chem 170 with your host, me, Dr. White. This is our last week together. Oh, I'm sad because it seems like we just started. At least for me, it did. Went fast. All right, important things. This Thursday will be the final exam. We'll have no Zoom meeting at 1 o'clock. I will send out the password. Let me open up. I didn't. I should have. All right. Everybody see final exam information on your screen? Thank you. My morning class are the slowest thumbs up people you've ever seen. You guys are great. Thank you. All right. Uh, on Thursday will be the final exam for this class. It'll be at 1 o'clock. I'll send out the password. Before that, I'll post probably sometime Wednesday afternoon in D2L. I'll have the final exam PDF file available for your download. You'll have until Friday morning, 10 a.m. to take the final exam and upload your answers as a single PDF file to D2L. Take about 3 hours to finish it. In reality, whenever I give it face to face, most, like 99% of the students, are done in about anywhere from an hour 20 to an hour and a half, about 90 minutes. Once in a while, I have one student who wants to check over every answer multiple times. Usually those students take about 2 hours. So I'm giving you plenty of extra time. All right, final exam has 32 problems, 18 pages. Relax, students do good on my final exam. And some of the problems are multiple part. Never in Chem 170 have I ever, or will I ever give a multiple choice. The point breakdown is the following. General knowledge, 30 points. Nomenclature, 62 points. And reactions, 118. It adds up to 210. And what does that mean? That means there's 10 extra credit points. I count this like a double test, which is why it's 200 plus 10 bonus points. Now, for the final exam, the point breakdown in terms of from test 1, 2, 3, 4 material, on the final exam, there'll be 35 points from the chapters covered for test 1. For test 2, there's 60. For test 3, 58. For test 4, 53. New material, amino acids, proteins, etc., 4 points. And don't forget, download it. If you have any questions, email me during the final exam. About every 2 hours, I'll check my email. Thursday afternoon, Thursday night, and Friday morning. I'll start at about 7-ish or so, maybe even earlier. I don't know. And I'll check. Now, there'll be no Zoom meeting on Thursday because it's our final exam. Now, important, I will be posting the final exam scores along with your final Chem 170 grade by this Sunday, 1 p.m. or earlier on D2L. At that time, I will post an announcement and send you an email that all your scores, your final exam, your lab total, and your percent and your grade will be in D2L. I will not send out for the final your points for each question, just like I never hand back the final when it's face to face. Now, couple things. Use your exams as practice problems. Excuse me. Use your exams as practice problems. You have them, you can go back and use them again. And if you have any questions, feel free to come to my office hours tonight and Wednesday night if you need help. I'm going to be there. Remember, my office hours are from 5 until 6 tonight and Wednesday night. And don't forget, hand in your labs. Speaking about labs, over the weekend, I went through and made sure I had everybody's lab. So if you look in D2L, as of, what would I say, 1 p.m. yesterday, any labs that you put in their email to me have been graded, I think. If not, let me know. Now, I have a question for you. How many of you are able to see your lab scores in D2L? Give me a thumbs up. All right, so you can see your lab scores. In fact, put it in the chat that you can see your lab scores. Just say, yes, I can see it. That's not the chat. Anyone? All right, thank you. So, because one of your colleagues was having trouble seeing that, and I went in and I said, well, they're all there and set for you to be visible. All right, now, what I'm going to be doing today, first of all, I talked about the final. Today, I'm going to next go through test number 4, because I've handed it back. Most of you did really good. Thank you, and thank you on test number 4. And then I'm going to go through a few things. Then we'll do our last lab. Oh, it's our last lab. And then we'll get out. I'll let you go. All right, let's go through the test number 4 answers. Remember, I will cut this out from the video. Test number 4, which I'm going to cut out of the video, so I don't want it floating around the internet for the rest of the time, because my tests are similar, but not the same. Any questions on test 4? All right, if you had looked in D2L, not only did I put test number 4 score in there, and I also caught up with all the labs. I had a fun weekend, not really, doing labs and grading tests, both this and another class. Does your heart bleed for me? But anyways, I also have your test total, which is a total of your 3 of the 4 highest tests you've taken, and that's also in D2L. Any questions so far? I'm looking at chat. I don't know about you, but I'd have a question. Dr. White, what do I need to do on the final to get a certain grade? Good question. Let's cover it. That's not. This is assuming you've handed in all your labs. let's assume Z, not assume, Z is the sum of your 3 highest tests. If you hand it in, and the deadline is today, tonight, I'll get it graded soon, is your extra credit project. I'm ignoring the lab because if you handed in all your labs, most of you, like almost all of you, have gotten high grades, and your lab either keeps your grade the same or boosts it up a little. If you're getting an A, you can't get it any higher. If you're lower, it can boost it up. Now, if you look at your Z, you take 450 minus Z, that's the points needed to get an A. For a B, 400 minus Z equals the points needed for a B. I'll go one more letter grade. I don't think anybody's in this range, thank goodness. And that would be the way you calculate how many points you need for a C. Now let's go through on a calculation. Let's assume you did real good on the 3 tests. So that means your Z, and you didn't do an extra credit, is 300. To get an A, assuming you handed in and got good scores on your labs, you need 150 points on the final exam to just eke out, get an A. That's the minimum. Now, you're going to say 150 points. Remember, that's out of 210. And if you divide 150 divided by 275, it would be 75 points, which is the same as on an hourly. So 150 would be the same as if you just only got 75 points on an hourly. Most of you did much better. So this will tell you how to figure out how many points. Remember, Z is the sum of the 3 highest tests, And if you did do the extra credit, those points up to 10. And for an A, 450 minus Z is the minimum points you need for an A. 400 minus Z, the minimum points for a B. For 350 minus Z, minimum points for C. This is assuming you've handed in all the labs and you've gotten good scores. Now, a warning. A lot of you have done quite well on the exams, and your amount of points you need on the final is not that many. And you say, oh, I don't have to study for the final. I don't need that many points. And I've seen it a number of times. Students are in that situation. They don't study hard for the final, and they do poorly. And that drops them 1 or even 2 letter grades. I've had students where they should have gotten an A. They studied for the final like they did the hourly exams. They wound up walking away with a B or a couple times even a C. Don't let that happen to you. Study like you need every point on the final, but at the same time, know it's doable. Any questions on that? All right, there are a few things I'd like to go through right now. I just went through and how soap works, so I'm not going to do it again right now. But leaving my class, you should know 3 important things. And those are those 3 important things I'm going to go through right now. You should know how to describe with words and a general reaction what happens when you eat something with a fat or oil in it. You should know how to describe with words and a general reaction. What's the functional group in a fat or oil ester? In your stomach is acid and water, so the reaction is acid, and we say water, hydrolysis of an ester. And ester, you learn for test 3, acid, water, you get the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. Next, what happens when you eat a carbohydrate? And really, I'm talking about starches, but I'll still use the term carbohydrate. What's the key functional group here? Acetal, that's what holds glucose together in starches. So you have acid hydrolysis of an acetal. And for test 2, and I also put it on test 4, the general reaction acetal or ketal, acid and water, you get back to carbonyl, the ketone or aldehyde you would have used to make that acetal or ketal, plus the alcohol you would have used to make that. And for those who must, there's a 2. And in glucose, these are connected together. And the final thing I taught you last week, what happens in your stomach when you eat a protein? If I can spell it. And what's the functional group that holds amino acids together in a protein? And that's an amide. And for test 3, you learned amide. You don't have to, but I will. R and R prime can be hydrogen. And now in my stomach, there's HCl. I need a counter ion. That's why I'm not using H plus. And you get back the carboxylic acid you would have used to make that amide. Plus, since you're an acid, the amine is a base, and you get the amine salt of the amine you would have used to make that. Amide. So you should know when you eat a fat or oil, it's acid hydrolysis of an ester. Here's the general reaction, ester, acid, and water. You get back the carboxylic acid plus the alcohol you would have used to make that ester. When you eat a carbohydrate, it's acid hydrolysis of an acetal. Here's the general reaction, acetal, acid, and water. You get back the aldehyde or ketone plus the alcohol you would have used to make that acetal. And finally, when you eat a protein, what's the functional group in there? Amide, acid hydrolysis of an amide. Get back the carboxylic acid you would have used to make that amide plus the amine salt of the amine you would have used to make that amide. Any questions on that? All right. Now, if you notice, there's no amino acid protein problem set. And that's because there's not much to ask, but let's go through a couple important things about amino acids and proteins. Remember, an amino acid let's try that again. Has the following structure. And remember, the amino group is on the alpha carbon. Now, when R is not hydrogen, are chiral. So if I were to ask you draw a chiral amino acid, well, I'm lazy, so I'm just going to put one carbon. And this amino acid is chiral because this is a chiral carbon, the alpha carbon, hydrogen, carboxylic acid group, amino group, methyl, 4 different groups, and therefore it's a chiral carbon. And you should know that. And what are proteins? Those are 50 or more. Bonded together. And what's the key functional group in a protein? What holds proteins together? Other people call it a peptide bond, but really it's an amide. That's the key functional group. In a protein, and you should know that. Proteins are held together by amide bonds, which other people call peptide. Nah, it's an amide bond, and you should know that. Now, interesting story. How many of you know about uh, vitamins? How many of you heard the term vitamin? Thumbs up, people. I think most of you have. Now, when they were looking at molecules that were in our body that kept us alive, organic chemistry was still in its infancy in terms of identifying molecules specifically, what atoms are where and what types, what functional groups. And a bunch of organic chemists were studying things like amino acids and other things, said, oh my goodness, you know what it is? There are a bunch of amines, really proteins and other molecules, but they thought they were all amines. They're important, vital for human life or life in general. And they called those the vital amines. But organic chemists are lazy, so they shorten the name to vitamins. And that's how vitamins got their name. They were short for vital amines, but they're actually more than that. And some of them they miss because ascorbic acid, vitamin C, has no, guess what? Nitrogen in it, no amines, no amides, no nothing like that. And therefore, they misnamed it, or someone did, and they call it a vitamin. But vitamin originally was a shortened version for a longer word, vital amines. Now you know. You can impress your friends, neighbors, and loved ones. Now, I got a minute or two to kill before our break. Shh, don't talk. You didn't hear me say that. So, what can I tell you? All right, here's a little story I should tell you. As a PhD organic chemist, I know a lot of things in specific areas. I'm an expert. But because I'm an expert in one area does not make me an expert in other areas I know nothing about. Because you're an expert in one area, you're not an expert in everything else. Well, a lot of scientists don't learn that lesson. And a great story was when a really great organic chemist, how many of you ever heard of Linus Pauling, Dr. Pauling? Nope. Well, he did a lot of uh, elucidating certain key organic molecules vital for life. And somehow he came up with the idea if you take enough vitamin C, you won't catch a cold. How many of you have ever heard that? Good. Well, I see a couple of you have. It's not valid. It may help you stay healthy, but it's not going to stop you from getting a cold. Well, somehow Linus Pauling, Dr. Pauling, got it in his brain. This is true. And because he was very famous and intellectual, he got on news media and everything and said that, and people believed him, which you shouldn't. Because just because he knows organic chemistry doesn't mean he's an expert in medicine and everything in the human body. And it wasn't true. How can I know? It's about time he said that. I was in grad school, and one of my closest friends in our research group said, oh, I heard that. And he started taking massive amounts of vitamin C. Didn't get him sick from the vitamin C, but he came down with colds. I didn't take that much vitamin C. I didn't take extra supplement. I mean, he was taking lots of it. And I didn't get sick when he did. And I told him, look, I don't think that's true. You're getting sick with every cold. I think that's to do with your personal physiology or whatever, but the vitamin C isn't protecting you. So just because you're an expert in one area doesn't mean you're an expert in all areas. And that's the lesson, unfortunately, a lot of scientists and quote unquote experts don't know or haven't learned. But with that, let's take a 5-minute break. We'll come out back for the lab, our last lab together, and I'll let you out early today. Well, not early, normal time for a lab day. See you in 5. Come back at 1:55. let's get going. All right, something I neglected to mention earlier, tomorrow and Wednesday, I will be doing a review of the whole semester. Yep, the whole semester, tomorrow and Wednesday. I do it every semester. I teach one Chem 170. When I do my other class, I do an end of the year review. And this helps students come to class or watch the video. It will help you. So with that, let's do today's lab. Now, one of the things I've done this semester with the labs I wrote, because I wrote all the labs for Chem 170, because when I inherited it, I only have an hour and 50-minute time slot. The labs I had were, yep, stinky, awful. So I challenged myself. How can I come up with good labs that are educational, inexpensive, because the school isn't going to spend a lot of money on things I like to do, and fun for you? So I did, and today's lab is an example of that. Many of the labs deal with tests that organic chemists used before we had our modern electronic instrumentation to identify functional groups or other important things in a molecule. Does this molecule that comes from this product have a ketone, aldehyde? Does it have a double bond? Well, let's talk about today's lab, and that is identifying starches. Starches are carbohydrates, but not all carbohydrates are starches. Fructose and glucose are carbohydrate, but they're not a starch. Table sugar, sucrose, is a carbohydrate, but it's only two monosaccharides hooked together, fructose and glucose. But starches, cornstarch and other things like bread, rice, potatoes, they have huge amounts of glucose molecules linked together. Now, it's not a straight chain. And let's look at today's lab. Everybody see carbohydrates lab on your, hold on, yep, on your screen? Thank you. All right. Now, how do you identify a carbohydrate? You use tincture of iodine, which is potassium iodide and iodine solution. I'll explain why in a second. Use this mixture. And this mixture will turn from a reddish brown to a dark blue, really more dark blue, so dark you may even think it's black when added to any starch. This is due to a complex, the iodine atom, anion, trapped in the helix form of starch molecules and the hydroxyl of the starch molecules. And what we mean by that is scientists originally found that starches are more helical, like this. And you got little hydroxyl groups all along here. I'm not going to draw them all in here, in here. Now, if you add iodine, when the iodine gets in there with the hydroxyl groups all around, this is a red-brown. I'll call it a reddish brown. And when it gets inside, it turns a dark blue, very dark blue, almost black. Now, the problem with iodine, I2, it's a solid at room temperature. And it's nonpolar. And you know light dissolves light. So instead of using a solid, if you could have a solution and put a few drops of it, it'd be easier, make your life nicer. Well, this is not soluble in water. So what did they find out? If you take potassium iodine plus iodine, you get this iodine I3 anion. And this is now water soluble. And you can make a solution. And guess what? If you have a starch, this is also a red-brown color. And when you react that with the starch, because now you can make a solution. This is water soluble. This now is a dark, very dark blue. And now you have a solution. You can take a few drops and put it on things and find out, is there a starch in there? Not a carbohydrate, a starch, which is a polymer of glucose. Now, when you make this solution, Ki plus I2, this is called tincture of iodine. And you can buy it at local supermarkets or drugstores still. If I can spell it. And usually it's made in a solution of water and ethanol. Why that? Because when I was a little kid, like about 5 years old, everybody's parents had in the medicine chest in their bathroom a bottle of tincture of iodine. Why? Because that with the ethanol kills bacteria. So if you get a cut or a scrape, you put some on there and it will keep you from getting infected. However, the ethanol burns like heck. Oh, I remember oh no, I don't want that, it hurts. And you still get it. And let's do something real quick, or maybe not that quick. And just to show you, I'm not lying to you, not that I ever have. Everybody see on your screen, I just pick Walgreens because it's easy to find, iodine tincture USP. And if you scroll down, let's look at the label, helps prevent skin infection, 2% iodine, actually, but it's used for minor cuts, scrapes, and burns. It helps prevent skin infection. So when you were my age, your mother would put that down there. Now, by the time I was in high school, a company who made a lot of money, have you ever heard of Bactine? They were the first ones to find an antimicrobial compound, something that stopped infections or on your skin or when you got a cut or scrape that had no alcohol in it. They found another compound, water. They made a lot of money selling it to mothers saying, look, your kids won't feel any pain. It doesn't burn when you put it on. But anyways, today's lab, you're going to be testing some dangerous chemicals if we were face to face. And what are those dangerous chemicals? Now, you're going to be putting a small amount of the carbohydrate on a recrystallization dish. It looks like a little glass plate. And after, put a few drops of tincture iodine on the carbohydrate and record your observation after 1 minute. Let's take a look at first the following YouTube. I think everything's on YouTube except my high school and college graduation. Maybe my PhD one too. Everything else is there.
An important constituent of our daily food are carbohydrates, which we consume in the form of starch. Starch is a high-calorie food that converts to sugar during digestion. Starch is also produced by all green plants as an energy store. Today, we will conduct an experiment to test the presence of starch in potato, rice, sugar, and salt. For this, we will need iodine solution, which is yellow-brown in color. Note the change in the color of iodine as it is put on the rice and potato.
That's really tincture of iodine. See how dark
it turn the iodine blue-black. Put some iodine on the sugar cubes. The color does not change. Salt too does not change its color. This proves that sugar and salt do not contain starch, while the starch in rice and potato reacts with iodine to form a blue-black compound. Now the reaction is because the blue-black color is basically the formation of polyiodide chains from the reaction of starch and iodine.
It's time to help people.
And that's what you'd be doing all on one little dish. And let's look at the dangerous chemicals you would test. I'd have cut up some potato, some bread, and yellow cheese and white cheese. And I can come back and talk about that. Flour, cereal, sugar, honey, and cornstarch. And if you were to do it in the lab, here's the results. Potato, dark blue, bread, dark blue, yellow cheese, dark blue, white cheese, brown. I'll come back and talk about that. Flour, dark blue, cereal, like I think we use Cheerios, dark blue. Sugar stays brown like the video. Honey would also stay brown or does. And finally, cornstarch, yeah, it has starch in it. If you haven't figured that out, dark blue. Now, when we do this face-to-face, ECC doesn't allow me to buy, or won't go out and allow me to buy and get reimbursed for bread, cheese, flour we got in the lab. I bring in cereal, sugar and honey and cornstarch. I think we have in the lab for other experiments too. Well, 1 year when I was doing that, I had to get more cheese because I bring these things in. And a potato, I don't usually have potatoes in my house. Another chemist usually brings in one for me to use for his lab. And the bread, I'll tell you a funny story in a little while. Well, anyways, I went to my local supermarket. I go to Valley Produce and Meat Market. They had on sale their off-brand or house brand slices of yellow cheese, like American cheese, from Kraft. So I bought it. I brought it into the lab and we did this and it turned dark blue. Wait, it's cheese. But no, I looked at the label and guess what? It has filler, starch, and that's why. So next time we did the lab next semester, I went out and bought some more expensive white cheese. I read the label, no starch, and that's why it stayed brown. But the yellow cheese stayed, guess what? It went dark blue because it had starch in it as a filler. That's why it was so cheap too. But it was good, but still, we needed a lab, but I bought it, some for myself. And that's what that. Now, funny story. You haven't figured by now what my religion is, Gehen Gesund, Yiddish, Jewish language. Yes, I'm Jewish. So when I had to bring in the bread, I was thinking, what can I bring in that lasts forever and won't go bad? So I brought in some matzah. And you break it up and you have little pieces put in. It works like that. It's got starch in it. Well, anyways, Dr. Daly, who does a fantastic job of managing the labs, when I brought it in, instead of putting on the bottle with that bread, he put matzah. And students, where's the bread, Dr. White? I go over, where's the bread? He put it out. I see they didn't know matzah was bread. And so I had Dr. Daly change the labels for next lab. It says bread, and underneath and bracket, it says matzah. But they didn't know what matzah was. But anyways, don't forget, why do you add potassium iodide and iodide together to make tincture of iodide? Because you can make a water-soluble solution. Iodine alone, that video, he shouldn't have said iodine, should have said tincture of iodine. And that's why. And for this lab, guess what? There's some questions for you to answer too. Now, since it's the end, almost the end of the semester, it's important, and I'm going to send out an email that you get this in by Wednesday when it's normally due, and the deadline is Thursday because I need it before the end of the semester. And with that, I'm done. One of you is having problem with seeing the labs. Why don't you stick around now and I can help you for a couple minutes. The rest of you can go. So I can say, Gehen Gesund, be healthy, wear masks. I still am because of that Delta virus. Yes, I've had both shots and it will protect you, but still, I'm not taking any chances. Start wearing a mask. Ooh, that reminds me, I still have it here. Oh, where did I hide them? I'll have to show you tomorrow. But anyways, wear a mask. Make sure if you haven't, get vaccinated. Because if you've been following the news, 94, 97% of the people are hospitalized, really sick with COVID-19 are unvaccinated. Most of the people who are vaccinated, like 99%, get mild or almost asymptomatic symptoms, like none at all if you get it again, even though you're vaccinated. So you're a lot safer. You know, it's been in the news that, well, the efficacy has gone down. Yeah, you can still get it, but you're not going to get sick and in the hospital if you've been vaccinated. And all of you are over the age of 15, and therefore you're able to get a vaccine. They don't have to even pay for it. With that, Gehen Gesund. I'll see you tomorrow, except for one person who may want to talk to me. Goodbye.